Dear students, in this session we will discuss price elasticity of demand. The term was introduced by Alfred Marshall. Now let me first give a definition of what is price elasticity of demand. The coefficient of price elasticity of demand measures the percentage change in the quantity of a commodity demanded per unit of time resulting from a given percentage change in the price of the commodity. That is the definition of price elasticity of demand. Since price and quantity are inversely related, price elasticity of demand is always negative. And to avoid the negative number, we always add a negative sign before the coefficient. That is a point I will explain later. Now, denoting price elasticity of demand as epsilon P is equal to percentage change in quantity demanded divided by percentage change in price. Epsilon P, price elasticity of demand, percentage change in quantity demanded divided by percentage change in price is equal to negative of delta Q by Q divided by delta P by P. Negative of delta Q by Q divided by delta P by P is equal to minus of delta Q by delta P into P by Q. A negative sign is added to convert it into a positive quantity. Or if this negative sign is not added, you will get a negative number. You ignore the sign, consider only the magnitude of change. And the price elasticity of demand measures the relative responsiveness in quantity demanded to a change in price. Now, consider the demand curve Q, P and Q as usual, and the slope of this curve is delta P by delta Q, or if you take a quantity here and price here, then it is delta Q by delta P. We will not take the slope of the demand curve as a measure of responsiveness, whether it is delta P by delta Q or whether it is delta Q by delta P. If you take it as delta P by delta Q, when you calculate elasticity, it is 1 by delta P by delta Q. That is a point which we will discuss. So, we will not use slope as a measure of relative responsiveness. The reason, as we have discussed in the previous class, slope is affected by the unit of measurement. If you simply change the unit in which the quantity is measured, the quantity is measured from kilo, from quintal to kilo, from kilo to grams, the slope is affected and you will get a different measure of responsiveness. If a commodity is specified in quintals, if price changes by 1 unit, 1 quintal becomes 2 quintal. If it is in kilos, 100 kilos becomes 200. Elasticity, the measure of responsiveness become 100 from 1. So we will not use slope as a measure of responsiveness. Also, slope will not allow us comparison of commodities expressed in relative numbers. Expressed in different units of measurement. So, if we define the magnitude, the responsiveness of change as relative change in quantity by relative change in price, this relative change is independent of the unit of measurement and it is a pure number. It is a pure number. So, elasticity is a pure number independent of the unit of measurement. Also remember this, price elasticity of demand is always negative. And suppose that for one commodity elasticity is -3, another -2. We know that -2 is bigger than -3. But we will say that the commodity with the elasticity -3 is more elastic than commodity with the elasticity -2. And so remember this, we consider only the absolute value. Either you consider only the absolute value because for most commodities elasticity will be negative as price and quantity are inversely related, or simply you put a minus sign to ensure that the resulting quantity is positive. And remember this, elasticity measures relative change in quantity to relative change in price. As such, it is a pure number independent of the unit of measurement. Whatever is the unit of measurement, elasticity is not affected. Now, this is the formula for calculating elasticity. In terms of the in terms of calculus, this can be written as negative of dq by dp into p by q. Negative of dq by dp into p by q. Because, and this is the limit of delta q by delta p as delta p approaches to 0. If you have no confusion about the meaning of delta and d. And this formula is used to measure elasticity at a point on the demand curve. What I say is, this is one method of measuring elasticity, and this method is known as the point method. And in this case, we measure elasticity at a point on the demand curve, and this measure is useful if the change in price is infinitesimal. Infinitesimal means very, very small. Mathematically, delta p approaches to 0. Delta p approaches to 0. On the other hand, if price change is considerable, we use another method known as arc elasticity. Arc elasticity. And now, the coefficient of price elasticity, what is arc elasticity? If we use arc elasticity to measure the responsiveness of quantity demanded to price, instead of measuring elasticity at a point on the demand curve, we measure elasticity, the average elasticity between any 2 points. So, the coefficient of price elasticity of demand between 2 points on a demand curve is called arc elasticity. To explain this, consider a demand curve like this. consider 2 points A and B, and suppose that you connect these points with a chord and measure the elasticity at the midpoint of the chord connecting these 2 points. Instead of measuring elasticity at A or B, we calculate elasticity in the midpoint of A and B. We assume that we connect these 2 points with a chord and we calculate the elasticity in the midpoint of A and B. That is the concept of arc elasticity. And arc elasticity formula is used if price change is substantial. If price change is infinitesimal, you can use point method. Otherwise, the method is arc method. And to calculate elasticity using arc method, we take the average of the 2 prices and also the average of the 2 quantities, say Q1 and Q2, P1 and P2. Instead of taking P1 or P2 or Q1 or Q2, we take the average of 2 prices, average of 2 quantities, and the elasticity formula here is delta Q by Q1 plus Q2 by 2 whole divided by delta P by P1 plus P2 by 2. Instead of dividing delta Q with Q1 or Q2, we take the average of Q1 and Q2. Similarly, average of P1 and P2. This becomes delta Q by delta P into P1 plus P2 by Q1 plus Q2. Q1 plus Q2. Q1 plus Q2. Arc elasticity formula will give you the measure of elasticity between A and B rather than A or B, and it is suitable for calculating elasticity for substantial changes in P. And the point is, if you calculate elasticity at A using point method, you will get one value for elasticity. At B, another value. But if you are using arc elasticity formula, whether you calculate elasticity at A or B, from A to B or B to A, the value of the elasticity will be same. The value of the elasticity will be same because you are not calculating elasticity at A or at B, you are calculating elasticity in the midpoint. In the midpoint. This is applicable whether the demand curve is linear or whether the demand curve is non-linear. That is a curve. So, we have 2 methods to measure price elasticity. One is the point method, the other one is the arc method. Here also you can use the notation dq by dp into P1 plus P2 by Q1 plus Q2 using the language of mathematics. Now, there is a third informal method to calculate elasticity, that is the total expenditure method. Again, it is introduced by Marshall. Total expenditure method, and total expenditure of the consumer is equal to total revenue of the producer. You will get the same conclusion whether you consider it as total expenditure or a total revenue. And we know that total expenditure is equal to P into Q. P P into Q. Now, let me consider this with an example. A specific equation will be considered later. Px, Qx, total expenditure and elasticity, price elasticity. Now, let me define elasticity using the concept of total expenditure. Demand is said to be elastic. The meaning of elastic, inelastic, unitary elastic, etc. will be discussed in the next session. Anyway, for the time being, demand is said to be elastic if for a fall in price, total expenditure increases, or for a rise in price, total expenditure decreases. For a fall in price, total expenditure increases, and for a rise in price, total expenditure decreases. Then demand is said to be elastic. This is the range. Demand is said to be unitary elastic. If for a fall in price or for a rise in price, total expenditure is remaining constant. Total expenditure neither increases nor decreases. That is this range. Then demand is said to be inelastic. Demand is said to be inelastic if for a fall in price, total expenditure decreases, and for a rise in price, total expenditure increases. And that is this. For a fall in price, total expenditure decreases. For a rise in price, total expenditure increases. Now, if a commodity has elastic demand, a price reduction increases total expenditure. And as total expenditure is total revenue for the producer, if a commodity has elastic demand, it is advantageous to reduce the price rather than increase the price. If a commodity has unitary elasticity, whether the producer increases or reduces the price, total expenditure is not affected and the total revenue is remaining constant. If a commodity has inelastic demand, it is advantageous to increase price, as when price increases, total expenditure also increases, and the total expenditure is total revenue for the firm. So the total revenue of the firm increases. And as it is known to you, academic books have inelastic demand. So the producers, the publishers always increases the price, knowing very well that there will not be considerable reduction in the demand for the product, as academic books are necessary for the students. So this is price elasticity of demand, estimated by point method, arc method and total expenditure method.